Good morning to all. I am Geeta, Assistant Professor from ECE Department, Rohini College of Engineering and Technology. I am going to handle the subject on communication engineering. So here I am going to discuss about the topic on binary phase shift keying. So on completion binary phase shift keying, the students will be able to define binary phase shift keying, draw the block diagram of BBSK transmitter, binary phase shift keying. So this is the simplest form of the PSK is binary phase shift keying where n equal to 1 and m equal to 2. So the BBSK where the two phases, that is 2 dash of 2, are possible for the carrier. One phase this will be represent a logic 1 and the other phase this will be represent the logic 0. As the input digital signal, this will be changes the states, that is 1 to a 0, from 0 to a 1. So the phase of the output carrier, this will be shift between the two angles, this will be separated by 180 degree. So the other name of BBSK is the phase reversal keying or biphase modulation. The BBSK is the form of square wave modulation of a continuous wave signals. Then this is the block diagram for the BBSK transmitter. So here we are having the input as the binary data in, that is we are giving the unipolar signal. This will be given to the level comparator, that is the unipolar signal will be converted into the bipolar signal. Then we are having the balanced modulator. So in the down we are having the reference carrier oscillator, this will be connected to the buffer. Then the balanced modulator will be connected to the band pass filter. Finally we will get the modulated BBSK output signal. So here the balanced modulation, this will be act as a phase reverse switch. Depending on the logic condition of the digital input, the carrier is transferred to a output either in phase or 180 degree out of phase with a reference carrier oscillator. So the figure shows the semantic diagram of balanced ring modulator. So the balanced ring modulator, this will be having the two inputs. One is the carrier, that is in phase with a reference oscillator. Another one is a binary digital data. So here the balanced modulator, this will be operate properly. So the digital input voltage must be greater than the peak carrier voltage. This ensures that the digital input controls on or off state of the diodes D1 to D4. If the binary input is the logic 1, that is the positive voltage, so the diode D1 and D2 are forward biased and on condition, while the diodes D3 and D4 are reverse biased, that is this will be in off condition. So the carrier voltage is developed across the transformer T2 in phase with the carrier voltage across T1. So consequently the output signal is in phase with the reference oscillator. So here if the binary input is a logic 0, that is we are taking the negative voltage as the binary input, so the diode D1 and D2 are the reverse biased, that is this will be going to the off condition, while the diodes D3 to D4 are forward biased, that is these two diodes in on condition, that is there is a current flow will be done in the D3 to D4. So the carrier voltage is developed across the transformer T2 out of phase with the carrier voltage across T1. Consequently, output signal is out of the phase with a reference oscillator. The quiz question is based on the binary phase shift keying is the probability of error of differential phase shift keying is dash than that of binary phase shift keying. Thank you.